into one of four areas, or one of four categories. And the categories, the first one of them is the labeling problems. Okay. So like I said earlier, every object on the file system, every process, every user, and every network port has a label. If those objects have the incorrect label, Selinux will deny access. It will stop it from working. Okay. And Selinux is doing its job by stopping applications from working which have the incorrect label. There's a sort of an axiom of computer science: you can't possibly get the expected outcome, you can't possibly get the expected output if you feed it the wrong input. Okay, so you can't have a service working if you've got the objects labelled incorrectly. Unexpected or unusual configurations. Selinux likes defaults, and system administrators love changing defaults. So Selinux will stop system administrators doing silly things. Or things like running your web server on a non-standard port, like 666. Now you can totally do this with Selinux turned on, but you need to tell Selinux that you're going to do this. Okay? So again, the fault of the system administrator, not of Selinux. The third one, bugs. There are bugs. There's one or two. We've got bugs at redhat.com for a reason. You know, this is a pretty big bug database, and occasionally there are bugs in the target policy. Nowadays in Rails 6, the target policy is pretty decent, and actually the amount of bugs is pretty low. But actually there's a whole load of bugs in applications, and applications can do really, really weird things on the system. Those of you that have played with Selinux in a production environment realize that it checks a lot of things. So when accessing a directory, it doesn't just say, can you open the directory? It will check directories before it. It will check if you can sort of seek files in the directory, append files in the directory, all this kind of stuff. There's a lot of fine-grained permission checks with Selinux. Servers like Samba will access a directory in a totally different way, a totally different pattern on the file system than your web server. Okay? So you need to know exactly how the application accesses the file system, accesses ports, that sort of thing, and write very, very specific policy. And policy is fragile for a very good reason, is to keep the policy secure, keep it accurate. And last of all, you might still get hacked. You know, it happens. There are people out there who will try and crack into systems, and once your system's been compromised, Selinux can't do very much. Selinux can stop you from getting hacked. In certain situations, it can reduce the risk, but it's not a sort of one-size-fits-all. It's not an awesome security tool that will prevent hacking. That sort of tool can never exist. Okay. Okay, so let's talk about the first problem in a little bit more detail. Administrators can mess up labeling, and again, I'm pointing the finger at you guys. This is your fault. Selinux is doing what it's supposed to be doing, and is stopping nasty processes, files, being accessed when they shouldn't be accessed. So if you do this, for example, if you create your own SSH directory, and not use the one that's created by your profile automatically, if you do make directory /root/SSH, it will have the incorrect context, because make directory has no knowledge of what actual directory you're creating. It won't apply the Selinux concept to itself. If you do something like moving a HTML file from your home directory, where you've got a home context, move that file into your var www directory and host it by your web server, your web server will not be able to access that file. This is a pretty common thing with something like a web application, web software, it will have the wrong context if you do this. To show you what that looks like by example, so you can use ls, command I'm sure everyone's familiar with a $Z argument. And you'll see the first output says, okay, if I've just made that directory, the context, the Selinux context in that directory will be user home t. Okay. And it's not right. So your SSH directory with Selinux actually has a different context. It's SSH home t. It has a special rules, special permissions against that single directory. If you do the same with the index file or the HTML file, you copy that from your home directory into your web server directory and don't change the context, it will have the type user home t when it should have the type httpd syscontent t or httpd content t. Okay. This means that your web server wouldn't be able to access the files. It means that your SSH client wouldn't be able to access files in that directory. Okay. Now fixing this problem is incredibly easy because we've got rules in place to be able to fix this automatically for you. Command down bottom here, restore con, restores the context of these files. We've got a load of defaults in place, default rules that will restore these permissions for you automatically. restorecon dash with a capital R for recursive, dash V for verbose so you can see what it's doing. We'll reset these contexts for you. Your web server will carry on working again. No need to disable Selinux. Just run restorecon against these files and you're working with them. So let's give you another example. Okay, so if you've got Apache and you want to serve from a totally different directory, not using /var/dub, but using something like /srv/myweb, you want to host from a different directory. Selinux doesn't know about this configuration. It's non-standard. The reason Selinux is going to stop you from doing this is because you don't want your web server just reading any part of your file system. You want to read this very specific directory. So if you create this directory yourself, you'll have the context of var_t, that's the incorrect context. And now, we don't know about, Red Hat doesn't know about this directory you're creating, or what we can't add in every possible combination of directory, of course. So you need to add your own custom rule in for Selinux. Use the command semanage to change Selinux policy. fcontext will change a file context for you. -a will append or add a new context. You want to set the type to HTTPD syscontent T for all the files in /srv/myweb. Run restorecon against that directory, and it's fixed. You can then get your web server to serve content from that directory. Okay? No need to disable Selinux, just add a proper rule for it, much like you would with a firewall. You don't just disable the firewall just to open the port. You add a firewall rule in there. Okay. Again, for home directories, if you, for some reason you want to host home directories from a completely different place, then if you were to create this directory yourself, it would have type default T. Again, incorrect. Selinux will stop this from working. Add in a custom rule here. semanage fcontext, so you're going to change a file context. -a to append a new context. -e will copy the context from /home to your new directory, essentially. Run restorecon, off you, and you can go off again and you're working. Okay. Now, there's a lot of non-standard configurations which are really, really common. One of these examples might be running your web server on a different port, like 8080, is a very common port to run your web server. Or having your web server sending email. Now, I don't think you should want your web server sending email by default. That's a pretty bad configuration to have. But if you have something like forum software, or some sort of software which sends email alerts, that sort of thing, then you can just enable a Boolean. What that does is an if statement enables a certain sort of section of policy just for that. Okay. Just by flipping a Boolean on, you can enable a standard configuration. Another example is Samba hosting home directories. So by default, Samba shouldn't be able to access your home directory. This is quite a bad thing. But there's quite a standard configuration where you might want this. Just tick a flag, enable the Boolean, and off you go again. Samba can start hosting your home directories. If you want to see a list of all the Booleans, they've got pretty easy to read names. I think it's get -a, I think it is off the top of my head. It'll list a whole ton of Booleans. You can see if there's one you can flip, enable, and Selinux will start working again for you. Okay, so what does Selinux need to know at the end of the day? It needs to know that objects, like files and directories or processes, have the correct context. Again, if you don't label them properly, then Selinux will certainly break your system. But much again, like you've done a firewall rule, add the rule for Selinux, and it will allow the system to work again. Give objects the least reasonable privilege. Okay. You could spend a long time writing custom policy that's very specific, very fragile, and it might take a long time to write. But actually, at the end of the day, you just need to give it the least reasonable privilege. Actually, writing policy is incredibly easy, much like adding an IP tables rule, for example. And in most standard configurations, should work out of the box. If you're running your web server on default ports, then we've written policy to allow that by default. No changes necessary. Okay. So only if you're going to do something unexpected or weird, add your rule in and off you go. And if you're doing something non-standard, please tell Selinux. Don't just disable Selinux. Again, add that rule in there and you can carry on. So we appreciate that Selinux is a new technology for experienced Unix administrators who haven't used it before, or even just Red Hat guys who've not used Selinux before and find it enforcing by default on systems. In order to make it easier to use, we've added a whole bunch of documentation and manual pages. In Rails 6 only, we added 700 extra manual pages just for Selinux. They're actually incredibly detailed. So this one I've given an example is, if you do man httpd underscore Selinux, you can see the entire Selinux policy that affects your web server. And in there is the example section in the man page has things like, if you want to host your web server on port 8080, run this command, and it will add the rule in, Selinux will carry on working. If you want your web server to start sending email, copy and paste this command. It's as simple as that. Again, the documentation is really detailed, and useful information in there too. So writing custom policy. Writing custom policy can be necessary. If you're writing your own custom application that you want to be confined by Selinux, again, if there's no rules ready for it, it's not going to be confined. It can be useful for developers to write policy, or system administrators who want to run in enforcing mode by default and have their application confined. So start with the logs. Selinux uses auditd, as does a few other applications on the system. Just look in /var log audit, and you'll see all of Selinux messages in there. Okay. Some of them can be a little bit difficult to decipher at first, but you'll see they're in a very standard format. Spend a bit of time Googling or reading up, and actually you'll find that messages do actually make quite a lot of sense. So you can actually generate policy from log messages. And as I say, writing policy is far easier than it first seems. So if you've got your log, var log audit / audit.log, you want to look for all of the denials that are on your web server. So all of my HTTPD type denials. So grep them, and so grep for those log entries, pipe them into the command audit to allow, and you can just generate the policy for you. Now, obvious caveat here is that generated code is never going to be as good as handwritten code. If you can handwrite it yourself and have the time to do so, then it's going to be far better quality. But actually audit to allow nowadays, the generation policy is pretty reasonable. Okay? -m says is the name of the policy that you want to create. So in this example, I've got my HTTPD. Please review the file, have a look through the policy that's just generated before installing it. When you're happy with the policy, se module -I to install that policy into your system. So you might want to ship your own policies in your own applications. You've got developers who want to be running their applications with Selinux enabled. There's a tools like SEPolgen, and you won't get any points for guessing what SEPolgen does. It generates policy based on your application. Okay, it goes through and it reads your binary and says, okay, look, opening file over here, let me add a rule for that. Oh, you're writing a file over here, let me add a rule for that. And of course, generated policy is never going to be as good as handwritten code, but it can take a lot of the pain out of it, okay? It can make it a lot faster for you. When you're happy with the policy, install it with se module -I to install the policy. And in Rails 7, we're making a bunch of improvements to policy generation as well. Okay? So problem number 3. So what's another thing that can cause Selinux to break my system? Well, there can be bugs. There's always going to be bugs in some software. If you think you found a bug, don't just sit there and get frustrated at your computer. Come and tell Red Hat. We've got bugzilla.redhat.com for a reason. Raise a bug if you think you found one, and we will fix it. Okay? We can't fix stuff we don't know about, so please do come and tell us. A caveat against here is that obviously there's no SLA against Bugzilla. But if you raise a support ticket with Red Hat on the customer portal, you can have an SLA against your request. If you think Selinux is breaking your production application, if you think it's stopping it from working, raise a support ticket. Use the support contract that you're paying for, and we'll get it fixed for you. You might go and raise a Bugzilla, public one you can see, or private one. Let's say you've got the SLA there to help you fix any Selinux problems. Okay.